Hello. So let's continue from where we left off, and this is Essential R Part 2. So I will continue from where I left off after I had discussed about the variable types and how to subset the different variable types. For example, character vectors, matrices, lists, and data frames. So now let's go a little further down. As I already mentioned before, R has inbuilt data sets available for a quick analysis. So you can do data, as I mentioned before, and you see there are a lot of these data sets. You can use any of them. You can just do an attach, and the data set will come into your workspace, and you can handle it. So now let us look at a particular data set called iris. Iris is a small flower, and here I've given a link to Wikipedia where they give more details about this particular plant. It's a small flower, and there are three main species, and the petal and the sepal sizes differ in each of these. So you can do some quick analysis. So I'm going to first touch upon some of the most common operations you would want to do on data frames. So on any data frame, the first thing you want to do is to check the dimensions of the data frame. So you do dim and the data frame. So dim iris. So it says there are 150 rows and 5 columns. You want to take a peek at the top 5 rows. So you do head the data frame. So it will give you the top 5 or 6 rows. And a very important and a useful command to check out data frames is str. Str gives a very nice overview of the data frame. So here it says this data frame has 150 observations of 5 variables, which means it has 150 rows of 5 columns, and these are the 5 columns: sepal length, sepal width, petal width. All of these are numeric variables, and you have a species which is a factor. Factor just says different classes, and it says there are 3 levels. It means there are 3 different classes of species which are available in this data frame. And another useful function is call names, to check what are the column names of the data frame. So when you import an Excel sheet, you typically want to be able to, okay, here's a small mistake, you want to be able to see what are the column names in the data frame, that is your CSV file or Excel sheet. So yes, do call names data frame. And also you would like to typically also know what are the different types of variables of these columns. Useful command is sapply. Basically it takes sapply, works on vector, so it will work on a vector of columns and give you the class of each of those columns. So if I do sapply data frame and the class, it says the sepal length is numeric, sepal width is numeric, petal length and petal width are also numeric, and species is a factor, that is, it is a class type. So the 2 other commands are summary, which is if you have numeric data, it will, for each of the column, it will give you the minimum, maximum, the median, the first quantile and the third quantile. So for all the columns it will do that. So this is a good command if you have numeric data, but not so useful if you have factors and other logical kind of columns. And one more is str. We already saw that. It gives a good overview of the class. I can look at the top 6 rows of the data frame using the head, comma, the number of rows I'm interested in, or I can look at the bottom end row. So I use tail data frame 6, and as you already seen, we can subset the data frame. So I have the data frame and then the row vector and the column vector. The row vector, I say it's 1 to 6, that is rows 1 to 6 and columns 2 to 4. So I do that. It displays rows 1 to 6 and columns 2 to 4, or I can say display all rows but only columns 1 to 3. So it does that. Or I can say display rows 1 to 5 but all columns, which is something you can do by just leaving out the vector for the columns. So we already saw this. We have get the names of the particular of each of the columns of the data frame. Sometimes we would like to change the names to something that is something that's more we can manage better. So I change the names of the columns in the data frame from petal dot length and petal dot width I changed it to length of sepal, width of sepal, length of petal, and width of petal, so it is more easily understandable. So I changed it, and now if I check the column names, it will give me the new names. One command we typically use if your data frame is fairly small, that is around maybe 500 rows or 1000 rows, you can do this. You can use the view command. It'll give you a nice view. RStudio does this. It shows you each of the columns and the values in each of the columns, and if you go down, you'll see the species. So there's the Setosa species, there's a versicolor species, and finally there's a Virginica species. So you can take a view of the data frame other than the regular commands like str and summary. If you want to access a specific column by name, you can just say data frame dollar and the column name. So iris dollar species will give you all the values in that particular column. And now I want to subset by the value in that particular column. I want to say find out all iris dollar species which is equal to Setosa. So I give this double equal to sign, which is a logical comparison, and I assign it to a variable called a. So I just do this, and if I check a will be a logical vector, true and false. You see the first 50 are true and then everything is false, so which is what we saw in the iris data frame. The first approximately 50 rows are Setosa, and then you have the versicolor and the Virginica. So I've subsetted it, I got a logical vector. Now I can subset my data frame with this logical vector of true and false. So only pick the rows which are Setosa. Now I check the dimension, that is, what is this new subsetted data frame, what is the size of it? So it says 50 rows and 5 columns, which is all the values I got for Setosa data frame, where the species Setosa. And I check the column names. I already know the column name, which is what I set it. And now suppose for this subsetted data frame, which is B, I want to get the mean of the width of the sepal. I just use this function called mean, and I use the data frame and the column name. So I do mean width of sepal, and I get that, and I can display that mean width of sepal. So that's 3.48. Now as I said, typically in R, we if you want to do it for, we have done it for one column, we want to do it for multiple columns, and you can look at each of these columns as a vector. So you can just use sapply, which is a good useful command, which is slightly difficult initially, but once you get the hang of it, you can use it. So I'm saying do an sapply of columns 1 to 4, and for each of those columns give me the mean of the columns. So if I do this and I do m, it will give me the length of the mean of the length of the sepal is 5.006, width is 3.4208, length is 1.4, and so on. Now I have mentioned this in my earlier lecture, that if you want help on anything, you can always use the question mark and the name of the function. I want to look at box plot as this. Besides talking about essential R, I would like to discuss about this exploratory analysis, which you typically do when you get a new data set. So I want to look at box plot. So you can look at this particular function using the question mark, and as I said, it'll show up here. It'll show you how to use it, what are the arguments, what the values of the argument should be, and finally it'll also give you actually box plot will give you the range of the particular vector that your data you're trying to look at. So it will give you the minimum, maximum, the median, and it will give you the first and the third quartile. So I'm going to do a box plot of the length of the sepal, and I'm going to do that. So it shows that the median is at 5 centimeters, and it also shows the minimum and the maximum. So as I said, this whole session is about trying to focus on things that you typically use in R. So I'm trying to just focus on those areas. And one of the things you typically want to do is to display multiple plots, subplots within one big plot instead of one big plot. So here what I'm going to do is I'm going to use something known as par mfro C22. What this does is give me 4 plots with with two rows and two columns. So I'm going to set this par mf row, and I'm also going to set the margin space as 4422. That is at the bottom and the top and the side. You can just look that up what it does. And I'm going to do a box plot of all the length of the sepal for each of the columns to see how the data is for the length of the sepal, width of the sepal, length of the petal, width of the petal. So you'll see that it has now put two rows and two columns of plots, and it is very nice and easy to quickly compare. So you can see that the length of the sepal has a median at 5, and the width of the sepal has a median at about 3.4. So you can compare all of this in one shot. And typically whenever you set this par mf row, trying to set subplots, you will have to reset the display, otherwise every subsequent plot will behave in the same way. And another useful command when you're doing exploratory analysis is the pairs command. So this will take pairs of columns and plot them. So in this case you can see that if I take, for example, the length of the petal, and if I take this width of the petal, you can see there is almost a linear correlation. There's the positive correlation between the length of the sepal and width of the sepal. Whereas if I take width of the sepal and there is length of the sepal, there is also some sort of correlation, but not to that extent. So you can quickly visualize how the different columns in your data set actually relate to each other. That's a useful command. Now one of the things, as I said, R comes with these inbuilt data sets which you can use and to explore, to play around with R, learn new stuff, try new functions. If you're not familiar with how to use it, you can always use the question mark or the help and get the details. But now I'm going to go a little step ahead, because in the real world the data that you get will not be in a state that you can use it immediately like the inbuilt R data sets. So I'm going to use this Tendulkar.csv, which is the batting performance of Sachin Tendulkar, an Indian batsman, one of the most famous batsmen who retired recently. And I have actually got this data from ESPN Cricinfo, and I've stored it as a CSV file. And one of the reasons why I have included this in the GitHub link also is because this data set will give you a good feel of some of the real issues you will face in the data that you get from the real world, because it's not going to be clean, because you're going to have empty spaces, you're going to have some NA values in some of the rows and columns, you're going to have some extra weird character, and you'll have to clean the data before you actually start analyzing. So the first thing, I'm going to quickly check the help on read CSV. You can look that up, and it gives all the details of all the arguments and the values it takes. And I'm going to use string as factors is equal to false, otherwise it'll read each column as a factor. And I'm also going to say that if I see this hyphen value in this CSV file, I'm going to replace it with NA. So I'm going to execute this command. So it reads it, and I said I'm going to do a summary. So as I said before, for a numeric columns, it will give the minimum, maximum, and give the median and the first and the third quartile. I'm also going to do a string, which I find a lot more useful than the summary, because it's saying there are 347 rows of 13 columns, and it tells me what is the class of each of these columns. So there's a class called there's a column called X, which takes a kind of a 1, 2, 3, 4, runs, which is a character, and mins, which is the minutes. It is again it's a numeric. So you can see more details in this. Then I'm going to look at the column names of this particular data frame, Tendulkar, and it gives me the column names. As before, I'm going to look at the top couple of rows of the data frame and also the bottom few rows. I'm going to check the class of each of these columns. So it tells you what the variable type is. So if you see, for example, runs is actually a numerical value, but it is actually written as a character because of the presence of certain other characters. So let us take a look at this data frame. What does it look like? We can use the view function as before, and if you look at it, runs is actually the runs is code, but you find that there are values like D and B, then there are values like the star. There is also other values like TD and B, which is team did not bat. DNB is did not bat, that is he didn't play in that particular innings. And there are a lot of NAs, and there is a star, which means that he did not get out, he did not lose his wicket while playing. So typically this is the thing, first thing you have to do is to clean this. So what I'm going to do is I'm going to get in this statement, what I'm saying is get all rows where the runs is not equal to D and B. That is, I'm not interested in these rows. This row is not is meaningless because it did not bat and it does not give value. So I'm going to remove this. So I want to select all rows where it did not bat, and I'm going to assign it to a variable A. And then I'm going to subset this A will be a logical vector, which I can just show you here. It will be true and false. I just want to pick all those rows, so I just need to subset it. So I use all columns. By skipping out the column I say all columns, but I just pick the rows for which the row is true. And if I check the dimension from 347 rows, it has now come down to 330 because it has removed all the DNP rows. Next I'm going to remove all the T DNP, which is the team did not bat, and I'm going to subset in the same way. And next I'm going to also remove rows where he was absent in the game. And now if I check the size of the data frame, it's only 329 rows from the original 347. I'm going to remove the star character. So one way to do that is to do a substitute the star character with with nothing. So basically it's typical of how you would use it in a Linux or a Unix kind of environment. Very similar to that G sub, that is a global substitute. And now if I look at the data set, and if I look at the runs, you'll find that the DNB and the TDNB and the star have gone, but you'll find that there are still some NAs, which means again it's still not completely clean and not ready for prime time, and you cannot really use it for analysis. So there is one more very useful command which I suggest that you commit to memory is complete cases. You can look this up using the same help command, and it'll find it'll remove all. It'll tell you which cases, which rows are actually fully have all values. So I again find all the rows which are complete, check it up, and so this is I check the length of this logical vector, which is 329. And if I want to if I have a logical vector with trues and falses, and I want to only count the number of trues, I can just sum the logical vector. It will just sum all the trues. So it says there are only 327 trues and there are 2 falses. So what I'm going to do is I'm going to subset this data frame with this logical vector. And now if I see the size of the data frame, it's going to say it's 327. So this is a totally clean data set. So now if I look at the top 10 rows of using the head command, everything looks clean. I can also look this up here in the data frame. It will all be sorry, let me just quickly so it's now refreshed, so it's all nice and clean. So I can do my analysis on this. Let's quickly do some base plots, which is another aspect you would want to use once you have cleaned the data. So I'm going to plot runs versus the runs he scored versus the balls Tendulkar faced. And since the balls face is in character, I'm going to convert it as numeric variable. I just do as numeric, and if I do this, the plot, it will give me a scatter plot of Tendulkar's runs scored and balls he faced. So it gives you all this, but but if you notice, this does not, the labels for the x-axis and y-axis are not proper, so I can just use the same function, but in this case I change the xlab, which is the x label, x-axis labels and y-axis labels to proper labels, and main is going to tell me the title of the plot, and pieces gives a different, instead of these hollow circles, it'll give me a slightly different uh, uh, icon for it. So now it gives me a filled kind of diamonds, and I can see that it looks a lot better. So I can use this, and the x and y axis are properly labeled, I get a proper title. Now I can do a quick linear regression line by using the lm command. You can check that up using the question mark lm. So I just on the y-axis it is on the x-axis it is runs, and the y-axis is ball faced, and the output value is the feature is runs, and the output variable is balls faced. So if I try to fit a regression line, and I draw a straight line through the, so it has now fitted a linear line, regression line through the data. Another way to export the data is to use the histogram using the hist command. So I just say hist, so what is the frequency of runs that he scored. So if you see Tendulkar, he has scored runs in a lot of runs, about 140 of this falls in this 0 to 20 range, and the 20 to 40 range is about this much, and so on. So this is a plot you would typically want to use. Now I'm going to go a little bit further down and look at how to use a very important package. I mean, it's almost impossible to avoid using this package, and because it's a very nice way to manipulate data, and that is the dplyr package, which was created by Hadley Wickham, and who is also the author of many more very popular packages. So whenever you want to install a package, you do install.packages, and within quotes the package name dplyr. Since I've already installed, I'm now going to I've now invoke this library, and I'm going to check the column names of Tendulkar quickly. We have already seen that, and the way previously the way you would select columns is you use the $sign. We saw that, but instead of that, in dplyr you can just say select the data frame, and then you can directly give the column names as it is without any of the $sign. So I just say df select data frame and the names of the column as it is. So if I check this new data frame df1, it will be a subset of the data frame, and has properly selected the columns. Okay, I can a better way to write this is to use this pipe command, which is this percentage greater than symbol percentage, which is so here it's once you get the hang of this, it's very convenient and very elegant. So the same data frame, what I do is the data frame is Tendulkar, and what I do, I pipe that data frame to a command called select, and I select the rows, the columns, runs, minutes and balls faced, and I assign it to a data frame df1. So if I run this and I do df1, it is exactly the same effect as the previous one, where I did a select with the data frame. I can also do a filter where if I want to select, will select the columns. Filter, you can select filter out rows which meet a specific condition. There are very complex conditions that you can add. So but here what I'm going to do is I'm going to get all rows where the runs is greater than 50 and runs is less than 101. So I'm going to just say filter data frame and then the condition, and if I check the top 5 rows of this new subsetted data frame, it's going to show in the runs all values which are greater than 50. And as before, I'm going to execute it. I can just use the pipe command. I can use the data frame, then the pipe command and filter, and within that I give the condition. I can also do an arrange if I want to sort the filtered commands, filtered rows, and then if I do this, it's going to give me all rows where the runs was give me all the runs, and it will arrange it in descending order. That's what I have mentioned it here. So it is the runs, the highest he scored was 248, and then 241, and so on. Another useful command is to group group common by some common value if they are repeating value. So for example, Tendulkar, if you see, he has played the ground. There are many matches he played on Melbourne, Johannesburg. You want to group by the grounds and find the average. If you want, you can do things like you can group by ground. So I do that. I check the new data frame, which is group by ground. And now let us do something more complex. What I'm going to do here, as I said, dplyr, the power comes with the command and the ability to pipe the output of one command into the input of the next command. So what you can chain commands like this. So I'm going to take the original data frame Tendulkar. I'm going to group it by ground, and then I'm going to summarize. What the summarize does is I can find the mean of runs. Other ways you can sum up runs, or you can find the mean of runs, or you can find standard deviation, whatever, of a particular entire column. And I assign that to a new column named mean runs. And finally, I'm going to arrange this newly created mean runs in descending order. So if you see, we just chained. We took this data frame, we grouped it by ground, then we found the mean of the runs in each of these grounds, and finally arranged in descending order. So let us do this. If I do this, and now if I try to display this particular data frame, you'll find it has grouped it by ground, and it has given the mean runs in each of these grounds. I can go one more step further. I can take the same data frame, group it by ground, find the average runs in each of these grounds. Then there's another interesting command which I suggest you also try to get familiar in dplyr, is mutate, where you can compute some value based on the column vectors. So here what I do is I take the computed value, that is the average runs for each of these grounds, and then I take the sum of that is the sum of all the average runs. Basically, I try to find the percentage that is scored in each of these grounds, and then finally I arrange sort the entire subsetted data frames in descending order. So this is what I do here. So if I do that, again I can plot this. Not plot this. I mean, we can let us take a look at what this new data frame looks like, where we have group by ground, found the mean, arranged it in descending order, also found the percentage in each ground. So it says in Multan he has scored the average is 194 and it's about 6.75%. Leeds is 193 and it is 6.73%, so on. Now let us do a bar plot of this. So I've taken a bar plot. I take the average runs and for each of these grounds. So I do this. This is a base plot. So it displays a nice bar plot over the average of a score over each of these grounds. So continuing on with R, some of the essential aspects of R. Another important thing is ggplot. This is called grammar of graphics, and originally the package itself was created by Hadley Wickham, who was also the creator of dplyr, and the grammar of graphics was originally, I think, created by another person, the definition of that. So let us look at that. So I just call a library a ggplot since I want to use it, as I've already installed it. So it is attaching that. And the way ggplot works is you can again just add things in bits. You can just chain together things to make your final plot. It's called the grammar of graphics. You can just add one by one components. So here I use this data frame Tendulkar, and I say there is something called aesthetics. Here I say aesthetics is x is equal to x-axis. I'm going to use runs, y-axis is equal to balls faced, and I'm going to say it's a geom point. That is, I want a scatter plot. I'm interested only the points. So I execute this, and then I add to this new variable p, I add the x label, y label, and I also add the title. So add that next, and then I just display this variable p. So you can see that I've just added all in one by one, and so I get a nice plot ggplot, which is very commonly used in R. So it has x-axis runs, ball phase, and the title, and very nicely done. Now let's say I can do this in one step. I can just say ggplot data frame, the aesthetics, then it's a geom point, the label. I can do this in one shot. And as I said, you can just add things very easily instead of the separate. Previously we saw we added add a lm function, and then we did a ab line. Here I'm going to just add something called geom smooth, which will create a smoothed out regression line using the lowest method. So I just do everything in one step. It creates a plot. It also draws a nice smooth regression line using the lowest method, and it also gives this shaded gray area, which gives a 95% confidence interval of the runs scored and the balls faced for Tendulkar. So one more thing I wanted to quickly do. We saw the iris data frame. So I'm going to filter by Setosa again, and we did the pairs. We saw that. I'm going to select the length of sepal and width of sepal, and this is how we did this in Setosa, but we can do the same thing in a single line in ggplot. As ggplot, I want to show you one more thing, which is very interesting, is that here we did it for only one of the species. Here in ggplot, you can do it for all the species. All you need to do is you give ggplot data frame, and aesthetics you say length of sepal and width of sepal. Colors you give as species. You say it's a geom point because you want a scatter plot. You want a smoothed out lowest method, and then facet trap. It's what it will do is it'll do the same thing for each of the species, and here I'm saying tilde species. So you're going to do that for each of the species. So it has done this. Now if I look at this, it has done scatter plot for each of the species, and also fixed a nice smooth line, done all the labeling, etc. in a single line. You can do it in ggplot. One more, couple of other packages you would want to use. Another important package is lubridate, which allows you to handle date fields, and typically data that you typically handle will include date fields, and lubridate again is by Hadley Wickham. So it can handle dates in almost every possible format, DMY, YMD, MDY, or DD hyphen MM hyphen. You can handle in almost any format. So once you have assigned the date, let's say you can do YMD, so you can say year, month, and date. I run this, and then I can check the day of this particular date I gave. It is day is 4, month is 6, and year is 2011. I can, let's say I have a new format that is month, day, and year, and I have a hyphen. I can just give MDY, and it creates this variable end for the end date, and I can now do all sorts of interesting stuff like finding a time span between the end and start. And if I display this, it says it's 61 days. I can do arithmetic on these variables, date variables, with lubridate. Okay, and so here I want to show you some interesting thing you can do with lubridate. So I've taken we have seen Tendulkar, and Tendulkar, if you see his data frame, there is a start date, and the date on which he scored these specific runs. You can do a nice moving average of his game by just using lubridate to look at this. Lubridate actually create a date variable using this particular format, and then I just use ggplot, and I say use this new variable new data frame runs, and the asterisk is start date, and then so I plot the date he scored these runs, and I say it's now I want a line. The geometry is line, so I want a continuous line of the runs he scored. I also want a smooth regression line fitted using lowest method. So I do that. You can see it gives a nice smoothed out moving average of the runs scored, and where you see all these peaks is what he scored over the period of time from 1990 to 2010. And one last package I would want to I think the strength of R is the fact that you have a package for almost every purpose and everything that you can imagine. So all you need to do is to go to Google and say R package and some handle dates, or R package to convert currency, or manipulate data frames or clean data frames, and you'll obviously it throws up all sorts of packages for logistic regression, linear regression, multivariate regression, Bayesian inference, whatever. There's a package for that. So here's an interesting package which will convert local currency into any other currency. So here I just do install. This package is not installed, so I probably need to install it. I just call install packages and within quotes the package name. So it will install that. So let it install. In this case it is installing this package, and the cool thing about this package is that it actually gets values in real time from Yahoo, and actually you can use that to convert from one currency to another. So which is pretty nice, and you can do all this programmatically if your data includes currencies from different countries. So for date you have Lubridate. For things like local currency to some other currency, you again have this package called QuantMod. So that is the main power of R, is the fact that you have a package and things done for you for almost every possible function that you may think of. Okay, so now it has installed this package. Now I call this package by calling the library function. So now I want the two currency is Indian rupee, Singapore dollars, Japanese yen, and New Zealand dollar. So I just do that, and the from currency is US dollars. And this function will actually get the exchange rate for each of these currencies. And as I had already mentioned, you don't need to memorize, you don't need to know, just Google, and I found the snippet in Stack Overflow, which was very convenient. So I just use this, and so I now get the exchange rate for each of this. So Indian rupee 65.41 65 rupees 41 paise as of today, and then the Singapore dollar is 1.4, and Japanese yen is 113 for the US dollar, and so on. So as I said, in R there is a package and thing for everything. So this second session in Essential R basically focused on how to subset data frames, and also touched upon some of the more important packages you would need to use more often, like dplyr, lubridate, ggplot, then baseplot, and the need to be able to clean data frames before actually using them, and the kind of plots that you typically use, that is bar plot, box plot, scatter plot, line moving average, things like that. So this is the second session, and in the last and final session I'll touch upon how to create markdown files, what are the essential aspects you need to consider, and how to publish those reports, and how to create a simple toy shiny app, and finally about R packages. Thanks for listening.